Overbooking the circuits is one of the ideas behind packet networks. Another one is to make everybody transmit the same size chunks of data. And if you think about this, let's think of an example using the postal system. I could take this book, and I think I have to put Scotch tape here and there to conform to postal regulations, but I could take this book and I could scribble in handwriting an address on the back and put some stamps on here and throw it in a box on the street, and the postal service would deliver it for me. I could take my briefcase and put a mailing label and some stamps on it and throw it in a box on the street, and they'd probably deliver it. Can you imagine how much trouble this causes people who have to design sorting and transmission systems at the post office? They have to handle postcards this big and briefcases in the same letter reading machines and canvas bags and trucks. It'd be enough to make somebody go postal. Now, what would you say if the post office came up with a proposal and they said, we are going to drop, not raise, but drop the price of a first-class stamp to 6 cents. And you're only allowed to transmit 1 page of paper per envelope. But 6 cents. Still sound like a good idea? Well, I don't know. I haven't figured out the statistics yet, but regardless of whether it's a good idea or not, my requirement isn't to transmit individual pages of paper. My requirement is to transmit these big random-sized files. And the post office says, no problem, just use more envelopes. And what you need is a box called a packet assembler disassembler. And what this box is going to do is take your big file and start grabbing standard size chunks of data out of the file. And so it'll open up your file and take the first standard size chunk of data out of there, fold it up, and then put it in a network envelope. And write the network address in the front, and then it'll take the next chunk of data. And it'll end up assembling your file into a whole bunch of packets, each with a network address on the front. And we put a big rubber band around there. And we throw this in a mailbox, and at 5 o'clock somebody comes along and empties it into a canvas bag. And then they drive it to a sorting station and dump the contents of the canvas bag onto a conveyor belt. And our bundle of 75 envelopes arrives at the first sorting station, the first network node, the first router, whatever you want to call it. What happens to our bundle of 75 envelopes at that point? Well, they take the rubber band off and then drop them on the floor. Bend down, pick up all 62 envelopes, except the ones that slipped underneath the sorting stand. Now picture this, you're the mailroom clerk at the receiver. 4 days later, the first 18 envelopes arrive. And over the next week or so, the rest of them percolate in, except a bunch that are missing, but you don't know that. What do? Start opening the envelopes and trying to find page numbers to figure out what's going on? No. You're the mailroom clerk. You're not allowed to open the envelopes, and even if you did, there's no reason to believe that there would be page numbers. So clearly, in addition to having the network address, we'd like to also have some control information so that the mailroom can resequence them, notice that some are missing, and unbeknownst to the user, call up and get the ones that are missing retransmitted. And then once they've got all of the envelopes, they feed them through a packet disassembler, and it grabs the data out of the packet and then throws the envelope away. We don't need it anymore. And it reassembles these chunks of data until we've reconstructed the whole file at the far end. What we ended up doing was transmitting this thing through a system that only handles these. And this is what a packet switched service from the phone company is all about.